for one. So first of all, it's probably worthwhile mentioning what a projectile is. So a projectile is an object on whom the only force acting is weight. So it will follow a curved path, something like that. Okay, and it follows that curved path because it has constant horizontal speed. And is accelerating vertically due to its gravity, so that's why it's getting steeper and steeper all the time. Right, the vertical velocity is increasing. Our example, right, an arrow is fired horizontally from a bow by an archer standing on the top of a cliff. The initial horizontal velocity of the arrow is 12 meters per second, and the arrow reaches the ground after 6 seconds. And then we've got these 5 bits to go through. Okay, and it's always worthwhile being clear in your head, is this to do with horizontal, is this to do with vertical? So this is for learning outcome 2, I should have said. So A is to do with horizontal. Now you can just use an H, but obviously when I'm doing a worked example, I'm going to go in a bit of detail. Right, write out the full word horizontal. Well, I'll post this video, so maybe you just copy the answer and refer to the video for the question. But so, what do we know about it horizontally? Well, the information we're given in the question is that the speed of it is 12 meters per second. And we're told the time is 6 seconds. Now we discussed the other day, remember, time is a scalar quantity. So it doesn't have a direction. So the time of 6 seconds applies both to the horizontal and the vertical. But in everything else, it's really important that you keep the horizontal and the vertical separate. So that 12 meters per second is a horizontal velocity. It doesn't apply to the vertical motion at all. We're being asked a horizontal distance, how far out from the base of the cliff. Basically, we're being asked that distance there. And what we've just written in our previous note was, remember, that the horizontal speed is constant. So the equation for something with a constant speed is d equals vt. Straightforward calculation. So now it's your standard calculation. Okay, so it lands 72 meters away from the base of the cliff. And I'm going to have to flick backwards and forwards a wee bit between the screens to answer the various parts of the question. But the next question, draw a velocity time graph of the horizontal velocity for the 6 seconds. We've just said the horizontal velocity is constant. What shape does a constant velocity graph look like? Straight line, okay. So for part B, actually what we'll do is we'll squeeze it in over here. Right, now it's hard for me to use a ruler, but you of course will be using a ruler. Right? Even before I draw anything, the standard things I can put on a graph, label each axis with the units, and mark in the origin with the O. Okay, so if you can, always give values. So there's our nice flat line for constant speed. And we know the value is 12, and we know the value of time is 6, so it runs for 6 seconds at 12 meters per second. C is going to ask us, determine the vertical velocity of the arrow just before it strikes the ground. D, draw the velocity time graph for the vertical motion. And then E, using the area under graph, determine the height of the cliff. So, determine the vertical velocity just before it hits the ground. This is part C. The only information that we have in the question which is relevant to the vertical velocity is the time is 6 seconds. Right? We don't have any other vertical information. But what we can do is fill in some information for ourselves. So I'm going to put these in a different colour. It's fired horizontally. That means that the initial vertical velocity is 0. Now it can be very easy to get caught in by that, right? Caught out by that. That it will in the question it refers to the initial velocity. But if that's horizontal, that's not the initial vertical velocity. The initial vertical velocity is 0. Right? And in every example we've ever seen in Nat 5 or Int 2 before it, that was the case. It was always fired horizontally. The other thing is, we know it's accelerating due to gravity, so we know the acceleration will be 9.8 meters per second squared. So these two bits that I've put in black are not mentioned specifically in the question, but you can fill them in every question that you do, right, when you're dealing with the vertical parts of the motion. And now we've got enough information to be able to solve, to find V, the final vertical velocity. Right, so without those bits in black, you're not going to be able to do. The relevant equation for something that's accelerating, remember, is A equals V minus U over T. In the absence of air resistance, A is 9.8 for every projectile. V minus 0 divided by 6. Now V minus 0 is just V, so that simplifies a wee bit quite quickly. And now we're just rearranging to get V on its own. So we're trying to get rid of the divided by 6 that's with the V just now. So multiply both sides by 6. And that gives us V. So 58.8 meters per second. So that's the vertical velocity just before it hits the ground. We're not going to deal with it after it hits the ground because then you're introducing other forces. But all the questions that you'll get will be really up to this point. So you often hear the phrase like, at the instant it hits the ground. That's what it's meaning. We know that eventually it's probably going to stop, but we're just working out what happens up to that point. Then we're asked to draw the graph of that motion. So once again, we're going to use the answer that we just worked out. This object is accelerating. What shape does a graph have for an object which is accelerating? Not a curved line, no. A diagonal line. And we know it's going to end up at 58.8. It starts at 0, ends up at 58.8. A nice diagonal line for the motion there. Okay, the last part was what height is the cliff? Now height is just another name for vertical distance. But vertically it's accelerating, so we can't go with our standard distance, speed, time calculation. Okay? But it does give you a wee bit of a hint in the question. Right? That using area under graph. So when an object's accelerating, the only method that we met before summer of working out distance travelled was this area under graph idea. So if I go back now, that's the area there I've put in green. So it's a triangle. So the distance now, I know it might seem a bit of a pain writing out that phrase area under graph. The SQA do not recognise the abbreviation AUG. So if you abbreviate it more, you won't get the credit for writing the method, basically. Now, if you go on and use it, that's not going to be critical if you use it correctly, but just for the basic formula mark, you don't get it. For writing AUG, you've got to actually write the words out. In this case, that area under graph is just a simple triangle, a half base times height. And that's a half. The base is 6 seconds along, and the height is the final velocity, 58.8. And that gives us a total distance of 176.4 metres. Okay, so the cliff is 176.4 metres high.